This video is presented to you by www.testprepadda.com. Dear students, in the previous sessions of set theory, we talked about different sets, subsets, and their representations. In this session, we will learn relationships between different sets by means of diagrams, and these diagrams are known as Venn diagrams. And for this we take the help of rectangles, we take the help of circles. In the previous session, we also learnt about universal set. Now, what is universal set? Universal set is a set of all elements of a group under consideration. It is a set of all elements. Now, in diagram, we represent this universal set usually by a rectangle. We draw a rectangle to represent universal set. And subsets of this universal set are represented by circles. Now, elements or members are written inside the circle. If I take a universal set U as A, B, C, D, E, F, G, H, I, J. These are different elements of universal set U, and two sets A and B. A as D, E, F, G, H, and B as E, F. Now, if I draw the diagram, then for universal set, I will draw a rectangle and set A here. Different elements are there. Since A, B, C, these three elements are not the part of A, so neither A nor B, so I'll write A, B, C here, then D, E, F, G, H. Now you can see E and F, these two elements are there in B also, so I will draw another circle B. So this is U, this circle A, and this is B. Now we can clearly see that all elements of set A and B, all elements of set A and B are there in universal set U. And you can see U has two more elements I and J, so I'll write here I, J. Now you can see all the elements which are there in A and B are there in universal set U. So A and B are subsets of U. A is a subset of U. B is a subset of U. And each element of set B is in set A. So B is the subset of A also. Okay, but each element of set A is not there in set B. So A is actually superset of B. A is the superset of B. This is the way we represent diagrams. We represent different sets with the help of diagrams. Now we will learn about the operations on sets. Operations on sets. Students, in mathematics, we are taught addition, subtraction, multiplication, division in lower classes. Plus, minus, sign of division, sign of multiplication. All these are actually mathematical operators. When these operators are operated on a pair of numbers, we get another number. For example, if I write 15 plus 3, I get 18. So this plus operator is operated on two numbers 15 and 3. And this way we get another number 18. Similarly another operator minus. So 15 minus 3 we get 12. 15 into 3 we get 45. 15 divided by 3 we get 5. In the same manner, we perform some operations on a pair of sets. To get another set. Now we are going to learn about those operations. First is union of sets. First, I will write here union of sets. The symbol that is used for union is this. Consider two sets A and B as A is equal to different elements are 5, 6, 7, 8, 9, 10. Set B as 6, 8, 10, 12, 14. Then A union B. A union B. This A union B will result another set which contains all the elements. This A union B, this set will contain all those elements which are either in set A or in set B, including the common elements. Means it is the set of all possible elements which are in A and B. Please note that common elements are not repeated. Okay, so we have to select elements which are in A or B. So what are those elements? You can see 5, 6, 7, 8, 9, 10, 12, 14. These are the elements which are either in A or in B. Now, diagrammatically, Venn diagram if I write, first of all, a rectangle for the universal set. And now set A. The elements are 5, 6, 7, 8, 9, 10. Now set B. Set B, 6, 8, 10, 12, 14. This is B, this is A. So what is A union B? For A union B, I will show you with another color. You can see if I take this portion, this will cover, or this will have elements which are in either in A or in B. So the shaded portion represents A union B. Got it? And in set builder form, if we try to write this in set builder form, it will be written as A union B is equal to all values of X such that X belongs to A or X belongs to B. All values of X such that X element of A or X is the element of B. X belongs to A or X belongs to B. Got it? Now, if I try to find B union A, if I try to find B union A, then it will be what? B union A. Again, you will say all those elements which are either in B or in A. So clearly you can say 5, 6, 7, 8, 9, 10, 12, 14. So basically A union B and B union A both are same. Since both are same, means I will write A union B is equal to B union A. This is commutative law. So operation of union obeys commutative law. Does it obey associative law? Let us check. First of all, what is associative law? It is A union B union C is equal to A union B union C. So again, if I take A as 5, 6, 7, 8, 9, 10. These are the elements of set A, and B is equal to 6, 8, 10, 12, 14. These are the elements of set B. Then what will be B? What will be A union B? A union B is equal to 5, 6, 7, 8, 9, 10, 12, 14. Now take another set C is equal to 8, 9, 14, 15. So what will be B union C? So here we will write all those elements which are either in B or in set C. So I'll write B union C as 6, 8, 9, 10, 12, 14, 15. Okay. So what is now A union set B union C? So I'll take all those elements which are either in set A or in set B union C. So I'll take 5, 6, 7, 8, 9, 10, 12, 14, 15. So this is A union B union C. Now we know B union we know A union B. So if I try to find A union B union C, means I'll take all those elements which are either in this set or in set C. So I will write 5, 6, 7, 8, 9, 10, 12, 14, 15. So you can see this set and this set both are same. So we can say A union B union C is equal to A union B union C. So the operation of union obeys associative law also. Got it? If I ask you what will be A union phi, then you will say all the elements which are in set A or set phi. As we know, set phi does not have any element. So A union phi will be what? A. Got it? Now I will talk about another operation of sets, and that is intersection of sets. Intersection of sets. The symbol that is used for intersection is this. Consider two sets A and B. A is equal to 5, 6, 7, 8, 9, 10. These are the elements of set A, and set B as 6, 8, 10, 12, 14. Then A intersection B will result another set which contains all those elements which are common to both A and B, means the elements belong to both A and B. So what are those elements which are there both in A and B? You can see 6, you can see 8, now you can see 10, 5, 7, 9. These three elements are there only in A, while 12 and 14, these two elements are there only in B. So A intersection B will be written as 6, 8, 10. These are the three elements. Now in Venn diagram, if I draw, first of all I'll draw a rectangle for the universal set U, and circle A, set A, 5, 6, 7, 8, 9, 10, and B as 6, 8, 10, 12, 14. This is B. So what will be A intersection B? The portion which is common. You can see the shaded portion. This is A intersection B. Now in set builder form, if you try to write A intersection B, A intersection B, then it will be written as all values of x such that x belongs to A and x belongs to B. Got it? And please note, in case of union, it was OR, and in case of intersection, it is AND. Okay, A intersection B is equal to set of all values of x such that x belongs to A and x belongs to B. So those elements which are common to A and B. Now, dear students, please note that operation of intersection obeys commutative law. That is, I can write A intersection B is equal to B intersection A. Okay, it also obeys associative law. Associative law. What is that? I will say A intersection B intersection C is equal to A intersection B intersection C. And please note, A intersection phi, this time it will not be A, because you have to write those elements which are common to A and phi, and we know phi does not have any element, so A intersection phi will be what? No element, so it will be phi. Got it? Now, distributive law. I will write this as A intersection B union C is equal to A intersection B union A intersection C. So distributive law is what? This intersection distributes over union. Okay? Now, if I draw Venn diagrams, different Venn diagrams. Consider this as A, B, C. So if I write A intersection B, A intersection B, then this is the portion. In Venn diagram, this portion indicates A intersection B. Now, here A, B, C. If I write B intersection C, B intersection C, it will be represented. This is B, this is C. So B intersection C will be represented with this portion. Now here again A, B, C, three subsets of universal set U. If I write A intersection C, then it will be represented with this portion. Okay. Now, if I write B union C, if I write B union C, this is A, B, C. Then B union C will be represented with B union C will be represented with this portion, B union C. Now, if I write A intersection B union C, A intersection B union C, then it will be, if I write this A, B, C, you can see this is B union C, and if I write intersection with A, then it will be the common portion this. Okay. Now, if I try to write A intersection B union A intersection C, then it will be as you see, A intersection B is this portion and A intersection C is this portion. So if I try to write union of these two, then it will come this. Then it will come this. So you can see this one and this one. The shaded portion is same. So what can we say? A intersection B union C is equal to A intersection B union A intersection C. So this is distributive law. Dear students, if two sets A and B, if I take two sets A and B in such a manner that A intersection B is 5 Consider this as universal set, this as set A, and this as set B. So A intersection B is equal to 5. So you can see no common element, and such type of sets are called disjoint set. Okay. Now if I consider two sets A and B as A is equal to 5, 6, 7, 8, 9, 10, and set B as 6, 8, 10, 12, 14. Then how many elements are there in set A? 1, 2, 3, 4, 5, 6. So cardinality of this set A is 6. Number of elements present in set A is 6. And what is the cardinality of set B? Number of elements present in set B? It is 5. 1, 2, 3, 4, 5. So if I ask you how many elements are there in set A union B, means what is the cardinality of set A union B? Then I'll find A union B, all the elements which are there in either A or B. So I'll write 5, 6, 7, 8, 9, 10, 12, 14. How many elements are there? A 1, 2, 3, 4, 5, 6, 7, 8. So the cardinality here is 8. You can see three elements. Three elements are common. 8, 6, 10. Three elements are common. In general, we can write the number of elements in set A union B is equal to number of elements in set A plus number of elements in set B minus number of elements in set A intersection B. So we remove the common elements. Got it? You can prove here 6 plus 5 minus 3, and that comes 8. 6 is the cardinality of set A, 5 is the cardinality of set B, and 3 is the number of elements in set A intersection B. So we have got here an important result. Similarly, if there are three sets A, B, and C, if there are three sets, then we can write an A union B union C is equal to an A plus an B plus an C minus an A intersection B minus an B intersection C minus an A intersection C plus an A intersection B intersection C. This is another result. Now I will talk about another operation on sets. Difference of sets. The symbol is simply minus sign. If I consider A and B as two sets, then A minus B is difference of two sets. It means set of those elements which are in A but not in B. So if I write A minus B equal to, in set builder form, I'll write this as all values of x such that x belongs to A and x does not belong to B. All the elements which are in A but not in B. For example, if I write A is equal to 5, 6, 7, 8, 9, 10 and set B as 6, 8, 10, 12, 14. Then for A minus B, I will select those elements which are in A but not in B. So I cannot take 6 because 6 is there in B. I cannot take 8 because 8 is there in B. I cannot take 10 because 10 is there in B. So I will take 5, 7 and 9 from set A because these elements are not in B. Now if I try to find B minus A, if I try to find B minus A, it will be what? Since 6 is there in A, I'll not take 6. This 8 is there in A, I'll not take 8. 10 is there in A, I'll not take this 10. So B minus A will have elements 12 and 14. You can clearly see that A minus B is not equal to B minus A. Now in Venn diagram, if I try to draw, this is the universal set. This is A, B. So the A minus B, you remove that part from here which is there in B. So the remaining portion will be this. This is A minus B. Now if I try to find B minus A, again universal set. This is A, this is B. So B minus A will be this portion. So A minus B and B minus A are actually disjoint sets. Okay, so disjoint sets means the intersection is a null set, 5, empty set. Even A intersection B, that is, if I draw, this is the intersection part. Even A intersection B can be considered as disjoint. Okay, so A minus B, B minus A and A intersection B. These three are actually disjoint sets. Okay. This video is presented to you by www.testprepadda.com. Testprepadda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties, to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.